Welcome back, everyone. And now that you know how to plot points using a polar coordinate system, what we're going to do is we're going to look at how to convert between coordinates using a polar coordinate system and those using a Cartesian coordinate system. So what you have in front of you is a picture of both the X and the Y Cartesian coordinate system and a polar coordinate system, and you will see that when we label the horizontal and vertical distances from the origin, x and y, that make up the Cartesian coordinate system, they also form the legs of a right triangle that has a hypotenuse r and an angle of theta with the polar axis. So we can easily convert between polar and rectangular coordinates. And the way to do that would be using these two equations over here on the right-hand side for x and y. And if we want to find the magnitude of r, we can apply the Pythagorean theorem. And if we wanted to find the directed angle, we can use this fact that the tangent of the directed angle is equal to the y-coordinate of the point divided by the x-coordinate of the point. So I'd like to show you a few examples of how to do that. So in my first example, we're going to start with a couple of polar coordinates, and then we are going to convert to rectangular coordinates. So I recommend starting yourself a picture, and my picture is going to have both the x and the y axis in it, and think about the pole here, and think about the positive x-axis as being the polar axis. So we are going to rotate from the polar axis to an angle of 5 pi over 6. We're going to draw the terminal side of our angle, and we're going to put a point on that that is 3 units away. So here is point P, 3 units away from the pole. If we were to draw the triangle that's formed with the x-axis, we could figure out the reference angle if we want. So if our directed angle is 5 pi over 6, then our reference angle is going to be pi over 6, and we know that the hypotenuse of that right triangle is 3. So there are two ways we can go about finding the coordinates for this point as Cartesian coordinates. One of them would be to simply take the hypotenuse and multiply it times the cosine of the directed angle, which is 5 pi over 6 for the x-coordinate, and for the y-coordinate, take the hypotenuse, which is 3, times the sine of the directed angle, which is 5 pi over 6, and that will give us our corresponding coordinates. You will note that point P has a negative x-coordinate and a positive y-coordinate, but as you are aware, the cosine of 5 pi over 6 is going to be negative, and the sine of 5 pi over 6 is positive, so the correct sign, plus or minus, will be assigned to those x and y coordinates. Another option would be to find the x-coordinate by taking a look at the reference triangle and paying attention to the fact that the cosine of pi over 6 is positive. So when you put your hypotenuse in there, you're going to have to throw a negative in front of it to account for that positive cosine of pi over 6. The vertical component, or the y-coordinate in Cartesian, would use the sine of pi over 6 if you're using the reference positive, but we have a positive y-coordinate, so we would simply use positive 3 for that. For my second example, I am going to the x and the y-axis, mark the origin or the pole, mark the polar axis or the positive x-axis, and we are going to rotate in a clockwise direction 200 degrees. So let's see, that's negative 90, negative 180, and another 20 degrees. So basically, we're going to draw our terminal angle, the terminal side of our angle right there, negative 200 degrees. And our reference angle is 20 degrees. We're going to plot a point on there, 2 units away from the pole, label it Q, so we know that R is 2, and we're going to draw our vertical and our horizontal components. So one way that you could find the Cartesian coordinates of point Q are to basically say x is equal to the hypotenuse, 2 times the cosine of negative 200 degrees. The vertical component of that reference triangle, or the y coordinate of point Q, is going to be 2, the hypotenuse of the triangle, times the sine of negative 200 degrees. Or if you prefer using the reference triangle, you can use that and simply say, well, I know that my horizontal component needs to be negative, but the cosine of 20 degrees is not negative, so I need to put a negative sign in front of that 2 to account for that. For the vertical component, or the y coordinate, we do not need to put a negative in front of the 2 because it is positive. Now I'd like to do a couple of examples where we convert from rectangular coordinates to polar coordinates. So I am going to again draw the x and the y axis. This time though, instead of rotating a directed angle, I am going to plot points as we normally have in the past. So move 1 in the negative x direction, move 1 in the positive y direction, plot point P here. And I am going to draw a reference triangle that has a horizontal component of negative 1, a vertical component of positive 1, and using the Pythagorean theorem, R, the hypotenuse of that right triangle, would be equal to the square root of 2. I could then use right triangle trig to find the reference angle. I'll call it theta. Theta is equal to the inverse tangent of y over x, or 1 over negative 1. If I use that, I need to be careful about the fact that the inverse functions give me restricted answers that are going to fall between negative pi over 2 and positive pi. The inverse tangent in particular is going to give me an answer of negative pi over 4 in this case, so I have to think about the situation and add pi to that. So once we add pi to that, or 4 pi over 4 to that, we get our directed angle of 3 pi over 4. For my next example, I have a quadrantial angle, which in some ways might be easier to deal with than the others. I am going to start at the origin and move 3 to the left and 0 in the y direction. So point Q would be right there. And the distance, directed distance, that point Q is from the pole is 3. And I need to use a directed angle of 180 degrees, or pi radians, or any angle that is coterminal with that. So point Q can be specified as having a directed distance of 3 and a directed angle of pi, or we could specify it as a directed distance of negative 3 and a directed angle of 0, or any angles that are coterminal with those, as long as we use the correct directed angle.